without any delay, I would like to invite Ashutosh sir to take the session forward. And I can also see that there are 73 of us are here. That great energy, guys. I highly appreciate everyone. So, without a further ado, I will give it just a brief introduction of Ashutosh sir. So, Ashutosh sir is a senior embedded developer, and he has decades of experiences. Has trained 10,000 plus students in the sector, and he knows every nuts of electric vehicle, you could say. So, sir, without further ado, sir, I would like to invite you to take the session forward. Thank you, sir. Over to you,
Okay.
sir.
Thanks, Asraf. Okay, thanks for everyone. Thanks for attending this session. Uh, just give me a little bit of introduction. Already, I have worked with many companies, Dana, Softcon. Right now, I'm working with DIYguru, and I work with many domains, maintenance project, and right now I'm working with embedded system with DIYguru. So I will try my best so that I will just give a brief. Okay, right now what is happening in the EV segment? Now, what are the niches? Okay, what are the niche areas in which you can target, and how the system is? Okay, no video. Don't worry. Okay, I will just share my slide. Okay, don't worry. Okay, video will be not be there. Okay, means I'm not. I will just share my screen. Okay. So we'll see everything that how the scenario is right now changing and how AI also changing the landscape of the job. So and in EV, what are the basic domains which we can target, and how the EV is going to be the upcoming, what I will say, market leader for providing jobs. Okay, so we'll see all these things. Uh, and in my session, I will say that whenever I'm asking something, जब भी मैं कुछ पूछ रहा हूँ, that is better you just participate in the session. Okay, and I just first of all apology from my side that I have joined late, little bit late, because here in Pune we have much more power cut here. Okay, okay, guys. So let me present here. Okay, my screen is visible to all everyone, right?
Yes,
Everyone.
sir, it is.
Okay, thanks. Okay, so first of all, we will see. Yes. Okay. Yes. So, so it is just a information that those right now who are attending this webinar, they will, first of all, they will get a official e-certificate of participation. Second, after the end of the session, you will get a link where you can download the EV architecture guidebook. And third, today we will be sharing one link. Okay, in that link, what is the means new about that link? If you are opening that link, or you're accessing that link, you will get the opportunity to appear for DET test. Okay, DIYguru entrance test. So you will be eligible to appear for the test if you are going through that particular link. So that I think someone mic is on. Okay, please make it off. Yes. Okay. So these are something. So first of all, you will get a e-certificate for the participation. Second, EV architecture guidebook you will get. Third, a exclusive link for the DIYguru entrance test. So these are the three things which you will get after the end of this session. So my first question to everyone. Yes. So in EV, right now we are able to see a comprehensive, what I will say, comprehensive change. Okay, because we are changing, mobility is changing. So we are moving from IC engine to electric vehicle, right? So in this, we can see that, okay, so we can see the scenario right now. Around us, we can see some two-wheelers. Around us, we can see some four-wheeler. In the two-wheeler, we are able to see what are the new things we are adopting. In four-wheeler, so many new things we are adopting, right? But my first question is, can anyone tell me what is the EV penetration right now in India in 2025? कोई बता सकता है अभी EV का कितना penetration है 2025 में? Anyone? Any guess?
2 to 3% for passenger vehicles.
No,
It's
I'm
higher.
okay.
Yeah.
Okay, I'm just asking for overall. Overall, what is the penetration of EV right now in mobility sector?
5%, 4 to 5%.
Yes, it is approximately more than 5%. It was near about 5% in 2024, and now it is approximately 7%. So you can see that, okay, in 7%, we are able to witness many two-wheelers and four-wheelers around us, and slowly it will increase. Now, what is the target for this? Now, the EV penetration should be at least 30%. This is the target what Government of India has put across us and across the many companies. And this is the reason why, okay, many companies are right now, some companies were earlier adamant that, okay, they will not go into IC, but slowly also right now they have witnessed that, yes, if we are not adapting to EV, if we are not going to EV, then it will be difficult for us, right? So EV, if you are adapting EV, that means also you are adapting many technology. One best example I will say here, Tesla. This year, Tesla has arrived India. What is the reason behind it? Because Tesla was getting tough competition from Chinese car makers, especially from BYD and other companies. Now, Tesla has entered India, other companies, because the day will come when Chinese company will also enter India perfectly. But right now, they were not allowed to access Indian market. Tesla has entered Indian market because they are getting tough competition from the Chinese, and the profit also were coming down. Recently, if you'll find out that before, I think 1 or 2 weeks before that, we got a news that Tesla nowadays, okay, more, I think they're more giving emphasis on humanoids rather than car. And the reason for this, because again, the Chinese car right now, in terms of technology, they are to some extent, they are far more superior than Tesla and other car makers also. Now, another example I'm saying, in 2024, there was a news that Volkswagen has shut down its one of the companies, not one of the factories, which was operated near about 100 years ago. मतलब 100 साल से कोई एक factory जो उनका चल रहा था जर्मनी में, they have shut down it. They have thought to shut down, but again, due to the pressure of this labor unions and all, they have not shut down. But the reason क्या है? What is the reason that these things we are witnessing? The reason is Chinese cars are, yes, in terms of technology, they are far superior. And one of the best example is BYD. And they are giving tough competition to European car makers, also to other car makers like Tesla. And now this is the reason why Tesla has right now thought that, okay, from car, we will shift slowly to the humanoids. Now we will make some robots, and that robots will come down in the market. Okay. So these are the scenario. Now, the reason is why the Chinese car makers are so successful. And the reason is we are witnessing that BYD is successful right now, but BYD already, it has started from late, means 1990s, it has started, and they have started with battery manufacturing, and now they are into car manufacturing. In 2012, there was a clip you can see in the YouTube that literally Elon Musk has laughed at BYD. But right now the condition is, okay, they are leader in EV. And after EV, the upcoming things is your hydrogen fuel cell and many other things are going on right now. I'm not going into that, but yes, EV is the best. Now, if you know EV, then you can go further into the further things, right? Now in EV, what are the new things we are going to witness that we will discuss? Now, little bit regarding this thing, that yes, there will be year-on-year growth. Definitely, we will see some growth. And also, if you see in 2024, the EV growth rate in India was, beg your pardon, approximately 5%. Now it is approximately 7% in 2025. Definitely, it will increase. The market expansion will definitely rise. Okay. Now, what are the other concern regarding this IC engine? Because yes, we know that IC engines right now, they are creating much more pollution. One of the great example right now is Delhi. Delhi has become right now a chamber, a pollution, means a gas chamber. Yes, many factors are there. Okay, because yes, the farmers are also burning their this crop and all. Apart from that, a major portion is also the fuel. What fuel we are burning in NCR region also. So all these things are there, and also for petrol and diesel, we have to give means a hefty amount to the in terms of foreign exchange. So in terms of foreign exchange, in terms of dollars, we have to pay means a big amount. So that is again that one of the major reasons why the government is thinking for renewables, for other alternatives. Okay. Now in other alternatives, EV is one of the main segment. Okay. Now going to the next, yes. So first question arises. So are we going to witness some it means development of other domains? The answer is yes. And the first domain which comes into mind is your domain related to the BMS, battery management system, domain related to the embedded system, domain related to software different vehicles. Okay, I'm not explaining all these things because I'm giving you overview that yes, that we in the near future we are going to witness many means era of many technology. Yes, AI is going to affect many things, and also AI is going to help us in EV also. If someone is having the knowledge of AI and he knows how to integrate AI with many things, for example, one of the best thing is BMS. In BMS part, uh, if I will give a rough idea right now, in India also, in if you want to find out a good BMS engineer, it will be difficult. There will be handfuls of BMS engineers are there who are present in the good companies. Yes, they have good exposure, and companies know. Okay, they knew that. Okay, who are the persons right now who are operating in this particular domain, especially BMS. And yes, it is a difficult one because I will come down. We will come down to that particular point. But yes, so there will be some domains which will be, again I will say, it will be very niche, it will be very specialized, and the problem is right now we don't have the proper skilled manpower for these particular domains. Now first reason is, now whatever curriculum right now we are studying, what is the engineering graduates are right now studying, the curriculum is already outdated. I have been to one of the NITs. I will not name that NIT, but I was surprised that in that NIT also in embedded system they are studying 8051. It is basic. I know that it is basic, but for engineering graduates right now in USA, the peoples are studying about 32-bit microcontrollers. They are dealing with NXP, Texas Instrument, Infinite Trico, or STM. So our students are dealing with 8051. And yes, one of the also I will say that difficult domain is embedded, because again we are dealing with hardware and software, and this is the scenario. So if our curriculum will not change, because if now in mechanical also you'll see that okay, mechanical or in electrical also we are more into the older domains. Okay, we are not moving into the new domains. There will be few university, few college will be there which are right now giving new things, okay, or new things or new domains or things related to the EV, or they are adding all these things into the curriculum. So these are the things, and that's why what the companies, basically the OEM or the major manufacturer of the automotive components, they are finding the proper skilled manpower in this particular segment, and this is 100% true. Okay. Now, so yes. So first of all, are we going to witness EV boom? Answer is yes, definitely, and it will continue for definitely for some years, because we are many I will say many research are right now going on in terms of uh, battery, in terms of battery chemistry, in terms of electronics. In electronics also right now, for example, we are using silicon carbide and gallium nitride. So how those things are also evolving the things. So all these things are correlated, and yes, research is going on, and definitely we are going to see a boom in this particular segment, right? Now, yes. So, now what are the domains? Okay, so we know that, okay, yes, there is a future for EV. If you'll see mobility, if we compare mobility with other domains, for example, IC and all, yes, the future of EV is definitely bright. And in this, what are the specific domains which we can target? Now, here, one of the major questions arises. Uh, I think before 1 month, I just got a call from one person. He was just working in a good company, and already he has, I think, spent 15 years means he has 15 years of experience in off-road vehicles. But he just told me that, sir, right now, the projects right now which are coming, they're all EV based, and they're working on BMS, but I'm completely blank because already I have, means before 15 years, I have done my graduation and all. These things are new, and I want to start from the scratch. The answer is yes, you have to start, because in IC the components were different. Because in IC, if you say we are dealing with engine and all, but here we are dealing with different components, different things, battery, motors, embedded system, sensors. So answer is yes, but how we will fill this skill gap, that is main important. Now I can see that there are, if I'll categorize the means skills, or not skills, I will say the manpower right now. So you'll find out there are a group of people who just want to change their domain. They are not finding, means they are not comfortable with whatever domains right now. For example, some is right now in programming part, he is not able to, he is not comfortable in that because AI is going to eat many jobs. Answer is definitely yes. So he just want to be in the core segment. Yes, definitely. For example, if someone is in electrical background, he already in coding part, but he is not enjoying that thing. So he definitely he can come down to the core. For example, uh, if you want to add something in the EV, or he want to come into the EV domain, right? So here right now in EV right now, which are the main things? So first, already I have said BMS is one of the critical thing, and it is very difficult because I will come down to that point. BMS, motor controlling, and then embedded system. In embedded systems, we have different types of protocols we are using, understanding of these protocols, understanding of each thing, how we can integrate different peripherals with the help of these protocols. All these are criticals nowadays. And yes, all these things are right now in the demand. Okay. So this is the scenario. Now let us move forward. Yes. Uh, in this session, what we are going to learn, first of all, so we'll see some basic regarding what is EV architecture. I will not go into deep. I will just give an overview here, and we'll see what are the different components we are using in EV and how these are different from IC. Second is your motor controllers, and means what is the function of motor controllers. Third, we will see regarding battery management system. And I cannot explain everything because yes, when you come down for the implementation part, okay, many things are there, many things. So if I start explaining CAN only one CAN protocol, it can take me near about 5 to 6 hours, proper 5 to 6 hours to understand, to make you understand regarding CAN only. Okay. So many things are there. It is not possible in a small webinar to cover all these things. Okay. If you're interested in this, all these things, definitely you can join, you can learn all these things. Okay. Now, fourth is regarding sensor system and integration. This is again one of the means important right now, the domain which we are witnessing, and we will see what are different types of sensors right now we are using in cars and automotives, right? And we will see now what are the different domains which are arising due to EV, electric vehicle. And at last, one slide we will dedicated regarding this scholarship and the things right now which you can get after this webinar. So the first, now let us understand what do you mean by EV architecture, uh, and how this EV is different from the IC engine. So we know that, and in an IC vehicle, basically the heart of the IC engine, and engine we are engine means, okay, we are dealing with either petrol or diesel or any other alternative resources. But here, if we'll compare with EV, in EV, what are the things? Yes, for EV, for energy, we are using BMS, or not BMS, we are using battery pack. In battery pack, if you say, only if I'm considering here lithium ion, okay. Many people right now, they are in the crunch that whether they are thinking that whether we will go for the domain change or not, and whether EV is good or not. The answer is definitely yes. And this is the right time because first of all, there are not many skilled person right now in these domains. And in these domains also need expertise. These domains also needs time. So means just by one day you cannot be a good BMS engineer, or just by one day you cannot be a good embedded engineer who is right now doing the motor controlling algorithm or dealing with the motor controlling. It will take time. So I will say that invest yourselves right now. If you're thinking that means you are not getting fun whatever right now you are doing. If you want to invest in your reskilling or skilling part, that is definitely yes, you should go for that. Okay. Okay, so let us see the what are the different how the IC is. I was in discussion that okay, how this IC is completely different from this motor. I will take your doubts. Anyone okay who is raising hand or anything else? Okay, I will take your doubts. Let me complete all these things, and at the end of this session, I will take your doubts. Okay. So yes, so this IC engines is complete. So its EV is completely different from this IC engine, and yes, in EV we are able to see different things. For example, the major things right now we can see that one is your battery pack. In battery pack, we have, for example, if I'll take one example, in lithium chemistry, if you'll deal only with lithium chemistry, we have many chemistries, right? For example, lithium phosphate, lithium titanate, lithium manganese, many chemistries are more than near about 5 to 6 chemistries are there. So yes, you are a BMS engineer. It is advisable that okay, you are dealing with the embedded part, or you have some expertise. Still, if you have knowledge regarding the little bit of chemistries, little bit of anode, which one? So if you are using one type of lithium batteries, in that which one is your anode, which one is a cathode, how it is behaving. So how lithium titanate is different from manganese, how LFP is different from titanate. Why LFP right now? Many manufacturers are using LFP. Okay, then if you say in batteries, different types of batteries we have, okay, pouch cells, and now we have blade cells. How the pouch cells are different from blade cells, how these blade cells are different from cylindrical cells. So all these things are very essential. So that's why I'm saying that yes. So this is one of the reason why this BMS battery management system is difficult. And if someone is into these things, yes, definitely it is what I will say niche area, or a domain in demand. Okay. So yes. So next is your electric motor. Right now, if you see in electric vehicle, we are using different types of motor. For traction, we are using different motors. In this example, in this we'll see, you can see that yes, we are using BLDC motor. Also, we are using PMSM motor. We are using AC three-phase induction motor. Okay, we are using other motors also. And in these motors, how each motor is different from others. Where is my stator? Where is my rotor? Where is for position sensor? What types of sensors I'm using? Now, the Hall sensor, we know that, okay, in BLDC motor, we are extensively using Hall sensor. How these Hall sensors are pointed, how we can derive the values from the Hall sensor, how the position is derived. So all these things we can say that okay, all these things are not easy. It needs some time. So when you expand, you will get to understand all these things. Okay. Next is your motor controller. Yes, we have right now we are using motors, different types of motor. But again, to control that particular motor, traction motor, we need a controller. Different types of controllers are there, different types of algorithm we are using. For example, for controlling, we are using different types. For example, for the basic is your PWM, pulse width modulation. In that, we are adding different types of algorithm. For example, field orientation control or DTC, direct torque control. Many are there. Okay, some might be using PID and all. So these concepts are extensively used, and you have to know all these things. And these things are very unique. But again, you have to invest time in this. Next is charger also. Charger, we have AC and DC charger. In how the AC and DC fast chargers are also there. In each charger, we have different types of connectors we are using. Each connector pins have a meaning. What is the meaning of all these things? What do you mean by onboard chargers? So related to chargers also, you need to invest many things. So as a whole, if we consider a EV, so 4 to 5 main things are there. One is your battery pack. For to control this battery pack, I need a BMS in a battery management system. In BMS, right now, I'm using a microcontrollers and different types of electronics. I will come down to that point. Other important components right now, what we are using, electric motor. To control this motor, I'm using motor controller. And the last one is the charger. Yes, for chargers also, we need to know many things. So if you compare this EV architecture, if you see this EV architecture, the main 4 to 5 components are there, and you do need know all these things. Okay. Now, okay. Now let us move to the next. Okay. Yes. Yes. So a little bit regarding how the means energy flow is there. So if you consider a battery pack, and if you see how these things are going on right now, from battery pack, so we are deriving energy in EV. We are deriving energy from battery pack, and from battery pack, it will come down to the motor controller and electric motor, and at last, we are energizing our wheels. Right now, these things is understandable. We know all these things. Okay, but again, we should know that energy is coming down to these things, but how we are controlling these things, that is very important. So in controlling part, embedded system plays a very vital role. In embedded system, if you see, many things are there. So if you see automotive embedded system, Now, okay, for this, let me write one thing here. First of all, when you are targeting embedded system in automotive, basically you will be dealing with ECUs and VCU. I hope that you guys have a understanding what you mean by ECU. Anyone, okay, who can tell me what you mean by ECU? ECU. What is the role of ECU?
Control
Yes.
unit.
Yes,
Indian
electronic.
control unit.
Yes. So this is electronic control unit, right? Now I'm just not writing this. So basically, if you'll see that in my EV, we have more than 70 ECUs are there. Okay, on an average, if you see there are more than 70 ECUs are there for to control each parameters or to control each peripheral. More or less, we are using one ECU. One of the best example is if you want to control motor. If for to control this motor, I need an ECU. And that this will be present in our motor controller, right? Motor controller. Now, another best example of ECU is your in BMS. So if I'm considering to control the battery pack, I'm using BMS. Now in BMS, I'm using a 32-bit microcontroller. Again, I'm using a controller here, microcontroller. Now, what are the other peripherals we have in EV? For example, we have, for example, I have a I'm using for controlling airbag system. Airbag system. In this airbag system, to control this airbag system, again, I'm using a 32-bit microcontroller. Next is our, for example, wipers, power windows. So to control all these peripherals, also I'm using microcontroller. Remember this. But at maximum scenario, I'm using 32-bit microcontroller. So I can say that if I'm using 70s ECU electronic control unit, in 70s ECU, maximum cases I'm using 32-bit microcontroller. And so now, what is the need of this time? You should know how to integrate a 32-bit microcontroller and how to play with 32-bit microcontrollers. Now, which are the major 32-bit microcontrollers right now which are used across this EV? So some of the names are, for example, prominent players in 32-bit microcontrollers are Texas Instrument, TI, NXP, your STM32. STM32 is used extensively. Okay. Now, Renesas. Yes, 8 mega and peak are there, but right now we are not using this. But maximum these things are used for motor controlling, for BMS, for sensors controlling. We are using either Texas Instrument, NXP, STM32, Renesas. Yes, another peak player is Infineon Tricore. So to understand this thing, first of all, you should know what is the architecture of a 32-bit microcontrollers. First thing, 32-bit microcontroller. Architecture of 32-bit microcontroller. And how it is different from other microcontrollers, right? Now, to program these 32-bit microcontrollers, I need to have understanding of some languages. For example, C, C++, at least these two languages. Okay. So if you want to write a program for these microcontrollers, 32-bit microcontrollers, so you must have some proper understanding regarding C, C++, and then again, data sets and all is there. Okay. So yes, so to work on these microcontrollers, you have to write the program, and where you can write a program in IDE, Integrated Development Environment. So this is a must that you must have proper understanding regarding IDE. So how you can write a program in IDE, how you can debug in IDE, how you can find out the errors and warnings and all these things, how you can use some tools like live executions and other things. Apart from this, also for debugging, you should know how to use oscilloscope and logic analyzer. This is very, very important. Okay, oscilloscope and logic analyzer. This is right now inevitable. If you are a engineer in electrical or engineering in electronics, I am surprised that the people are teaching in university. I'm regretting this thing to say. There are some professors who are already have done PhD, and if I'm saying that, okay, sir, it is better you can go for the implementation of oscilloscope, but still they don't implement oscilloscope or logic analyzer. But remember this, now this is the need of the hour. now stop working in Arduino, because Arduino is a basic 8-bit microcontroller, even if it is 32-bit microcontrollers. Okay, right now a new this new has been arrived that okay, Qualcomm has taken over Arduino. But again, I will say that the more you are into these microcontrollers, okay, these microcontrollers, you will see there are some specific series are there, from NXP or STM, which will only cater to motor controlling part. So there are some specific series from Infineon, okay, who are catering for the BMS part, right? So so you should know how to work with a 32-bit microcontroller if you are expecting to work in this particular domains. And yes, these domains are definitely difficult, but once you are into these domains, okay, you will not look back in your life. Okay. Yes. So C++, and ID and all, oscilloscope, you should know all these things. Apart from this, now in embedded system, what are the other things you need to know? The other things is protocols. Protocols are very important. Okay. Now in protocols, we are using which protocols? Can anyone tell me which are the prominent protocols right now we are using in embedded system for EV?
CAN.
Can?
Some other also there.
Yes.
UARTs.
Yes. So we have CAN, we have UART. Okay. For different purpose, we are using different protocols. Remember this. So we are using CAN, UART, definitely I2C also, SPI. But the purpose is different. Okay. Now, Lean also we are using. At some first, someone is also using, some might be using FlexRay. So these are, I'm just naming those important protocols which you should know if you are targeting at least embedded system in EV, FlexRay. But I'm saying, see, all things you cannot learn at a go. For example, you are starting with first four protocols: CAN, UART, I2C, SPI. Then you can move for the other. For example, Lean, FlexRay, or Ethernet, like that, right? So these are the things, but these are prominent. Okay, you need to know all these things, okay, if you want that. Because right now I'm surprised that a company was there. They have just put one vacancy for internship, and for internship they have mentioned that okay, they need someone who has expertise in 8-bit, 16-bit, 32-bit, in STM, across many IDs, across many protocols. So this is actually this is not what I will say is not justifiable. Okay, so you are expecting that someone who is fresher, someone is from the college, he's will be knowing 32-bit. It is absolutely wrong, because in the curriculum itself, okay, you are not teaching 32-bit, right? Now, how that person will get the exposure of 32-bit? That is the main issue. Okay. So these are the things. So if you're targeting, and yes. So once you know all these things, then it becomes to work on some domains. Okay. For example, if I am say AUTOSAR, ADAS. Now, what are the other domains? Okay. After knowing all these things which you can target, is one of the best is this AUTOSAR. I hope that if you know what even the AUTOSAR, ADAS, and then right now we are using one term, that software different vehicles. Okay, so all these things. Okay, so I'm just segregating all these things, but yes, now it become more easy to work on this, because in AUTOSAR the basic thing what you are doing is communicating between different ECUs. ECUs means again 32-bit microcontroller. So if you don't know how to work with a 32-bit microcontroller, how to work with the help of ID, how to troubleshoot that, then it becomes difficult. A person if say that no, I don't want to start with directly with AUTOSAR, yes, you can start, but it is better if you have a prior knowledge before that, to any prior knowledge of 32-bit microcontroller. Okay, in ADAS, what we are integrating, again, camera, lidar system, radar system, cameras, and others. So if you know some basic peripherals, how we are working, how to work with, how to develop algorithm with the help of MATLAB, how to simulate these things, camera, lidar, or radar, and some peripherals, how we are able to simulate this thing in MATLAB, then it become very easy, okay, to go on these things, right? So these are the some prominent domain right now, which are, I will say, related to EV, and these are very bright future, I will say. Okay, and in these segments you will find out there is a less skilled manpower in these segments, definitely, for sure. So let us move to the next part. Yes. Now, one question is there. Can everyone just see this question? I'm giving you 30 seconds and write your answer in the chat box. Okay. So which EV subsystem fails most frequently? So whatever you have the answer, you can just put that in the chat box. Okay. Everyone. This is visible, right? Everyone. ये दिख रहा है ना सबको? Am I audible?
Yes, sir.
Okay, this is visible, right? Okay, so in the chat box, you can give your answer. Okay, which EV subsystem fails most frequently? Okay, sensors, BMS, motor controller, and motor. Okay, so share your answer. Okay, I'm just waiting for 30 more seconds. That's all. I cannot check your answers. Okay, you just give this answer and you'll see. Okay. Now see, these questions we have taken because these things right now also we are witnessing. So when you are talking with many what I will say, those who are in the repair and maintenance, okay, they have said all this thing. Okay, that yes, if you'll see here, sensors, BMS, motor, and motor controller, the answer is your which one? Anyone? Yes. Now let me check. Okay, let me check what you have written in the chat box. Okay.
Sensors.
Okay, sensors. Okay. A motor. Okay. Minda sensors of Scorpio fail. Okay. Motor controller. So some is saying motor controller. Yes, the answer is correct. It is motor controller. Okay. Okay. The answer is motor controller. You just okay check this out, and we will see something. I will take your doubts. Okay. If anyone is raising your hands, okay, we will see all these things. Okay, later on, and I will say that if you want more deep deep means deep knowledge in these aspects, okay, better you can just connect with our experts also. Okay, you will get a proper I will say proper knowledge regarding this. Okay, yes, definitely the answer is motor controller, and we will come down to that particular thing. But first of all, we'll see now. We have seen that yes, so these are some prominent what I will say protocols right now we are using. Already I have explained a little bit regarding this, that CAN and UART and I2C. CAN is your controller area network, and UART universal asynchronous receiver transmitter. I2C integrated circuit, so stop distances. So these are some prominent I already discussed. So these are some what I will say communication protocols we are using in motor control, not in motor controller, total in EVO. You can see this. Okay. So how and among these, one I can say that what I can say that CAN is very important. In CAN, let me give one overview regarding CAN, little bit of overview regarding CAN. If we'll see CAN, so this is actually developed by BOSS. Okay, this is understood. So right now we are actually using two types of CAN. One is your standard CAN, and another is your anyone? One is your standard, and another is your extended CAN. Yes, good, very good. Okay, extended CAN. So
Yes, sir.
yes, so when we are going for to study this CAN, okay, so what are the things we need to study? This is very important. Not only CAN, it is also applicable to the other protocols also. First of all, you need to know perfectly the CAN. Here I am just saying these things, the CAN frame or any frame for any protocols, CAN frame. So in CAN frame, you have to understand, so which are the different bits and how this frame is made up of. First, for example, I'm giving a start of bit is there. Okay, so many are. Now we have arbitration ID. Okay, and then we have, so I'm just giving an overview here. At end of we have UAF. In here we have some RTR bits are there. Okay, and we have some DLC, and then data length of the data length means payload of the data length. Okay, and also here we have some CRCs there. So I'm just saying that, so we can see that in a CAN frame we have different bits, and you have to understand each bits. So when whether my SOF is recessive or dominant, so in end of my frame which type of bit is there. In data, what I can send means, for example, if you're considering your standard CAN, we can send 8 byte of data, right? So in extended CAN, what we can send, so for that, what we have to set. So in CAN, for example, apart from this CAN frame, we must have some understanding regarding what do you mean by dominant and what do you mean by recessive. So understanding of dominant and recessive. Apart from this, you should understand what do you mean by CAN high and CAN low. CAN high, CAN low. Then what do you understand by CAN controllers? CAN controllers. Yes. So all these things. Okay. So because these things, I'm just giving an overview. Many things are there. If I go explain startup bit and all, then you have to understand this thing properly. Okay. Then at which scenario I'm getting dominant case, at scenario which scenario I'm getting recessive case. So what is understanding between CAN high, CAN low? What are different types of controllers we are using now? Whether CAN is a address-based protocol or is a message-based protocol. So all these things are essential. So when you are targeting any protocols, okay, in protocols, you need to know, first of all, your frame is important. You should know whether it is a asynchronous, synchronous, whether it is a basis-based or address-based, uh, and means whether it has master-slave concepts or not, and different types of frames we can see from the protocols. Okay, so each protocols has some frame. UART has a frame, I2C has a frame, SPI has also a frame, CAN has a frame. So in knowledge regarding CAN frame or any other, if you're targeting any other protocols, frame is one of the important part. So you have to target that. You have to know all these things before we are going to the programming part of that particular protocol. Okay. So thus I was giving a overview regarding that. Next, let us understand. Yes. So in motor controller, what are the failures we are witnessing? Yes. So we have said that among these four, means in the questions I have said the four options. Okay, in that four options, we can say that basically we can witness that this motor controller has more more failure, right? So what are the reasons? So some of the reasons are there: overheating, phase imbalance, overcurrent, sensors mismatch. So there are some prominent reasons why this motor controller failure is more. Now how we can diagnose these things? Okay, means how we can find the failures. So for this, again, I'm saying you should know how to use the oscilloscope, because many don't want to learn how to use an oscilloscope and logic and other. But right now, remember this: these are basic debugging tools. If you don't know how to use them, then it becomes very difficult. If you are in EV maintenance or in EV you're working, or in embedded system you are working, so these things are inevitable and you should know all these things. Okay. Next is your BMS part. Okay, now come down. In BMS, we know that this is battery management system, and we have just mentioned 4 or 5 parameters, but there are many parameters are there, right? So we have state of charge, state of health, and we have, yes, and cell monitoring, cell balancing, thermal management, all is very, very important. We will see some aspects regarding SOC. Means in SOC, okay, what are the things right now we to find out? For example, SOC, we might be using voltage method, columns counting method, open circuit method. So we should know all these things. So why this particular domain is so difficult? Because understanding of these things are also very difficult. You will not find any proper, what I will say, source to know all these things, right? Okay. So for some advanced concepts, for example, we are using Kalman filtering. So how this Kalman filtering is used, or now how to develop this Kalman filtering, and Kalman filtering, what are the parameters we are using, and what even by the next is your SOH. SOH also, again, what even by electrochemical impedance methods, the spectroscopy methods, all these things are there. In cell balancing, we have active cell balancing, passive cell balancing. So what do you understand with these things? Okay, how we are able to do the active cell balancing and passive cell balancing, understanding of these things are there. Thermal management, in thermal management, what are the things right now we are applying, and how thermal management differs when we are approaching for different cells. For example, we have blade cells. What are the things we need to apply in for blade cells, pouch cells, and this cylindrical cells? So these things are there, and there should be a proper understanding regarding all these things, right? Yes, BMS, you know that because it's a brain of the battery, and there are some basic advantages. So right now, for example, we have seen many examples where Ola has got uh, caught fire, means it got fire, right? Okay. So what are the basic reasons? One of the basic prominent reason, yes, is your malfunction of BMS, or we can say cell imbalance. Many factors are there. So the BMS is very important, and right now the optimization of BMS is very, very important. And if right now I'm just giving one scenario, if someone who has experience of more than 4 to 5 years of experience in BMS domain, and that particular guy, he or she has worked in one good company and worked extensively for 4 to 5 years in BMS. Now the pay package is not less than 25 LPA. Remember this, 25 lakhs, or it is more than 20 LPA. So such is the scenario. And this I have already talked with many colleagues and all. So this they are actually paying. So if someone is having 4 to 5 years of experience in BMS, proper understanding of BMS, definitely he will be getting this amount. Okay. So these things are there, and the brand of the battery, we know all these things that yes, now the important part of the battery pack is your BMS, and how to control the parameters of the battery pack. We need to integrate this battery management system where it will control the different parameters. Now parameters are common, we know. For if you see, okay, let me name those parameters. Now, what are the parameters? Can anyone name them? So yes, we have voltage, current, temperature, we have yes SOC, SOH, depth of discharge, So all these things are basically controlled with the help of battery management system. And yes, in this battery management system, we are using 32-bit, or this maximum cases we are using 32-bit microcontroller. Okay, basically from Infineon or Renesas. It depends on the manufacturer. Okay, which microcontroller they are using. Okay. Yes. Next we have. Yes. Now let me. This is a little bit regarding the BMS architecture type. So we have some centralized BMS, distributed BMS, modular BMS. In centralized BMS, we have single master unit. You can see in distributed BMS, multiple units are there managing cell groups, and so the advantages are there for each types of BMS. Okay, so for example, if you see the distributed BMS, the multiple units are there, so it enhanced redundancy, better fault isolation, higher component cost, but complex communications. Again, a complex communications means again we have to work with CAN and all, and become very difficult. So if someone is going for these things, he should be also good in programming and all. So these things are there. It depends on the company, okay, which type of architecture they want, right? Okay, modular BMS is there. So these are some architecture type from the BMS. Next, yes. So this is one of the, I will say, basic question. If one cell overheats, what should the BMS do first? Everyone just answer this question in the chat box. So this is again a quick question. So if this is normal simple question, if one cell overheats, what should the BMS do first? You please write down in the chat, everyone. Okay, let me check. Okay, what is the maximum answers we are good getting? Okay, sorry. Yes, someone is writing C4 2. Okay, 1. Okay, Punit Pal. Okay, 1. Okay, 1. Okay, 3 2. Start balancing. Okay, alert controller. Okay, good that. Okay, you have. Yes. Okay, now let us. Yes, actually the option is first one. So first of all, it will reduce the current. Okay, I hope that you have gone through one of the videos right now, which is okay. We can see regarding to EV. Now the Chinese manufacturers, what they have thought that if there is a malfunctioning in battery pack or the BMS, what they are doing, they are just implementing one method, ejecting that particular BMS. Can you imagine? Now they are playing with that level. Now here we are not able to find a solution. Now nowadays also, in I think before 10 days or 12 days, we can find that 2 buses has catch fire. Again, that is different case. But again, EV also, we have seen that many times that okay, Ola has got fire. And so the Chinese has developed that if a they have working in a 4-wheeler, and what they have done, you can see that particular video in the YouTube also. So they have developed this, that once if the vehicle find out that there is an imbalance in cells, or if there is a short circuit in the BMS battery pack and all, so directly they can eject that battery pack. You can see that. So after the completion of the webinar, you can check it out, that particular video. Very interesting one. Okay. So I can say that on that level, China is now playing, right? So the answer is here reduce current, and yes, many can give answer, but this is the basic answer. It will reduce the current, right? Okay. Next, we have sensors. Yes, definitely. If you're going to integrate, uh, if you see in EV, not even EV. Okay, if you see any automatic, we have different types of sensors right now. For example, the best we can say that Hall sensor definitely we are using in BLDC motor, not only for the positioning, the many other purpose we are also using Hall sensor. Uh, can anyone tell me just in the chat box? Okay, just give me that apart from position sensing, for all what other purpose Hall sensor is used. Okay, give your answer in the chat box. I will check you. Let's check that. Just again, I will just write it down. Now that again we know that a Hall sensor we are using for position sensing, right? Now apart from positioning sensing, for what other purpose we are using Hall sensor? Give your answer. Let me see. Yes. I think Durga Pradas. Yes, correct. Bill. Yes, current measurement. Definitely. So apart from this, yes, there are, but these are some basics. Yes. So this Hall sensor basically is used for positioning sensing. Right now we are using BLDC motor, and also we can say that for current sensing also we are using BMS. This one Hall sensor, right? So all these things are there, and let us understand. I will just give a brief that what are the different types of sensors we are using. I will just name a few. Uh, yes, the first one for parking we are using ultrasonic sensor. Many sensors we are using actually. Okay, so if you'll consider EV, in EV we are using many sensors, right? And understanding of sensor is very important. Okay, the first sensor I will say is again we can say Hall sensor. Then we have ultrasonic sensor. Ultrasonic sensors. You should have proper understanding regarding IR sensors. Then we have temperature sensors. Temperature sensors. And then, okay, prominent what we are right now we are using MPU 6050. Anyone who has worked with MPU 6050? In MPU 6050, two things are there. One is your accelerometer, and another component is your gyroscope. Can anyone tell me where these two are used in EV? Gyroscope. Anyone? So I'm just specifying one name, but not means generic. We are using accelerometer and gyroscope. For which purpose we are using these two things? Actually, in this sensor, we can access accelerometer and gyroscope, right? MPU 6050. So where actually we are using accelerometer and gyroscope? Anyone? Write in the chat box. Write in the chat box. Let me check. Okay. Powertrain. Okay. Self-balancing. Okay. Anyone? Okay. For which thing we are using accelerometer and gyroscope? Powertrain and infotainment. Okay. One of the basic peripheral I'm saying. Okay. The best example is your airbag operation. Definitely. For your airbag operation, remember this. So when you are controlling airbag operation, for airbag operation, we are using many sensors. But one of the prominent sensor what we are using is this one. Sensor is accelerometer and gyroscope, right? So understanding of this sensor is also important. Yes. Now yes. So these things are there. So temperature sensors we are using, current sensors we are using, voltage sensors also we are using, position sensors and speed sensors. So these are some basic generic categorizations of the sensors which we can witness. Okay. So all these things are used. Next, what are the reasons for these sensor failures? Yes, definitely we have electrical noise, mechanical vibrations are there, moisture due to moisture also, because many times we can see that the vehicle is running through some level of water. Okay, so yes, it might happen that moisture has increased, thermal stress, calibration drift. So all these are prominent prominent reasons for these sensor failures. And we have some troubleshooting process. You can see this. Okay, we have 4 to 5 methods. Okay, we can troubleshoot this also, verify the sensor power supply, signal integrity using oscilloscope. Again, I said that okay, oscilloscope and logic analyzer are two things which are very important right now. You should know how to use them. Even if you are mechanical engineer, electrical engineer, or electronics engineer, irrespective of which type of domain from you are, you should know all these things. Okay. So yes. So right now the major question is, yes. So what are the career opportunities we are witnessing in EV system? The answer is yes. So there is a high demand for engineering roles. Definitely, BMS is one of the means one of the leading domain, and here definitely I can say that very few professionals are there. Understanding of BMS is not that easy, or means yes, means integrating so much of parameters. If I in the embedded system for the BMS battery management system, again it is not easy. Former engineer, again, if you're working in this bootloader and all, for startup code, former engineers, definitely they are in demand. Motor control engineering, okay, how you're developing different types of algorithms for to control both different types of motors. Yes, we are using BLDC, PMSM, and other BMSM is different from BLDC. So one type of algorithm is not suited for all types of motors, right? For each motor, we should know different types of algorithms. So these things are EV systems, testing validations. For testing validation, you should know different types of protocols. Again, Canoi, some is there, tools are there. Canoi, we have different types of tools. We have, you should know how to use the oscilloscope, logic analyzer. Many tools are there. Okay. Right now also, I just forgot that name. Okay, that thing also we are using. So these are some prominent domains right now. We can see that your already boom is there, and definitely in DIYguru also we are witnessing that we are getting many means requests from these companies. They are asking for 4 or 5 years experience in embedded, or 8, 9 years of experience. But in that, for that such type of experience, we don't have that particular skill sets. Okay, or skilled manpower. Okay, so these things we have already witnessed. Uh, yes. So now we are right now into the end of this webinar. Now I will request Ashraf. Ashraf, are you there? Okay. Okay, so this is the scanner. You can just scan to register yourself, everyone. And also, you can register for DT scholarship. Okay. And also, you can download free EV guidebook, but you have to scan and register
Okay.
here, everyone. Yes.
Okay, everyone. Thanks. So actually, it was got stuck. No worries. So I have here. So now we are coming to the offer part, that what we are providing today. So as you all know that every single day we have something for you, and this is what we have for you today, and this is really exciting. It is going to be. Before announcing it, just at this very moment, I would like to take a single minute to thank you, Ashutosh sir, that he has given a complete, like he has given a complete idea that how the EV architecture looks, how it is going to be, and what are the market conditions as well, and along with what are the future opportunities. So thank you, Ashutosh sir, for keeping the session really insightful, regardless of the roller coaster, network connectivity. We highly appreciate. I would like to give a thanks to you, regard on the, like, from the all the attendees presenting here. So okay, so now we are moving to the webinar offer which we were talking about. So at the very first, so before, like, really exciting announcement, this is for you. So I would highly appreciate everyone to be open for it, and like, let's start with it. So at the very first, the first offer is the first opportunity is the scholarship opportunity. So what is the scholarship opportunity? Basically here we are offering you all an exclusive scholarship to our DET test, right? So all you have to do is attempt the DET test right after this session, okay? And the session link will be open for 24 hours. No worries, we'll be keeping it open by tomorrow 11:59. Okay, so you have the complete weekend for you. So you could just go and attend the DET test. Like, it will be open for tomorrow completely. On the Sunday, you could take any time, just take 25 to 30 minutes of your time, just attend the DET test. And what you will be getting out of it? So basically, based on your performance, you will be eligible to get up to 40% off on our PG and non-degree programs, right? So make sure you don't miss, and this is only for today's attendees, right? So who are the people attending here? You could just scan it and just save it, or like just take a screenshot of it and save it in your devices. Or also, what I can do for you, that I'm sharing the link in the chat box as well. Just allow me a single moment. Just give me a second. I'm just copying the link and sharing it to your way. Here we go. Yeah, here I've dropped the link. So I would highly request everyone just save the link so you could appear for the DAT test, right? And this is only for the attendees who are attending today in the session. We are providing 40% scholarship opportunity. Also, now coming to the part, as we have mentioned about the 100% free guidebook. Yeah, it's right. We are providing 100% free guidebook. So for that, what you have to do? So it is linked with the scholarship opportunity, which is DAT test. So second, when you will be appearing the DAT test, you will be eligible for 40% off on PG and annual degree, depending on your performance and your score on DAT test, along with your counseling interview, which will be happening later the DAT test, right? I hope everyone is clear on that. Kindly acknowledge it once, then we could move to the free guidebook one. Could you please, could you all please create Jam 3.5? Thanks for the acknowledgement. Okay. Now we're coming to the second part, which is the free EV architecture guidebook. So whatever we have covered, whatever topics have been discussed by Ashutosh sir. So for that, Ashutosh sir has crafted this, like our team has crafted this guidebook for every single person, that you could easily understand how you could make a career in EV, right? So for that, we are providing EV architecture ebook. And for that, you have to just complete the DT test, and you will automatically receive our EV architecture ebook for free directly in your email, right? So again, I'm mentioning it is completely structured resource that will help you strengthen your fundamentals. So again, DET test is the key, right? You have to appear for the DET test to become eligible for 40% off on PG and annual degree program. Also, you will be getting free EV architecture guidebook automatically. Like you just complete the DET test, you just submit the DET test, and the EV career guidebook will be delivered on your mail, and also your score will be delivered on your mail, that how much you scored in the DT test. So it will be completely transparent, right? So I guess it's clear now. So again, DT test is the key. Attempt the test, unlock your scholarship, get the free ebook in your inbox. Okay. Test link is in the chat box. Also, you could take a screenshot, you could scan it, you could save it. So you have the complete day for it, right? Tomorrow you have the complete day for it. You could also take the DT test today. It will be taking just 30 minutes of your time. You could just arrange 30 minutes of your time and just go for the DT test. Here, the question is completely on the basic level, that as you are beginner in the EV, obviously questions will be in that, right? Obviously, they highly appreciated, and this is the first time we are providing this exclusively for our learners, right? So I highly appreciate everyone to go for this. No worries, we will be taking the questions later. Just a second. So now we're coming to the your e-certificate, right? Before moving e-certificate, I'm again mentioning it. The DT test is the key. Just save the link and just open the link and just do the 30 minutes test. You have the complete time of 24 plus hours, right? It's 9:30 now. We'll be closing the DT test link by tomorrow 11:59. So you have the complete day tomorrow. The complete Sunday will be yours. You could just take 30 minutes of your time and then just sit in the DT test, right? It will also be a self-evaluation of you, right? Great. Okay. So now I guess there's no confusion. Okay, okay. Okay, we'll be taking the okay. The PPT of this webinar will also be shared. Nothing to worry, Tilak. Obviously, if you attend the DD test, our counselors will connect with you. Obviously, you will be getting the PPT. Nothing to worry on that. Great. Now we are coming to the how you will generate your e-certificate, right? So I'll be sharing the link to generate your official e-certificate in this session only. In just a moment, just allow me a second. I'm just copying the link of generating e-certificate. Okay, it is copied and dropping it here. Okay, I have dropped this. Okay, I have pinned the link in the chat box. You could just click on the link and generate your e-certificate. There will be a couple of questions, might be taking 30 seconds of your time, and you will be able to generate your certificate by its own. Nothing to worry on that. If someone is not able to open the link, nothing to worry. Just save the link. Later, when you open it through Google, you will be able to do that. Nothing to worry on that, right? Okay. When you open the link through Google or Chrome, you will be able to open the link. Nothing to worry on that. Just save the link in the chat box. What I can do for you is that I'll be keeping the link open for another 1 hour, right? I'll be keeping the link open for another 1 hour. So whenever, like after the meeting, after question answer session we'll be having, you will be easily generate the link. The link will be open till 11 p.m. Okay, this is my call. That link will be open till 11 p.m. Nothing to worry on that. Okay, so just to give like how you will be generating. So just you will go to the link. Make sure you fill your details correctly. The name you enter will appear on your certificate. Again, just reminding you, don't forget to take the DT test for the scholarship and guide book. Right? You will share all links together in the chat, which I have shared it earlier, right? Okay, so once you are done generating your certificate, stay with us because right after this, we are about to open the floor for the question answer round. Ashutosh sir is with us. Like he's having difficulty in on the new network connectivity. Still, he is with us. This is the love he shows for our learners. This is the love he shows for EV enthusiasts, right? It actually shows that how enthusiastic he is when it comes to EV. So okay. So now I guess everyone like there is no doubt on the DT test and also on the e-certificate. Nothing to worry. What you could do you could like if someone is not able to open the link, you could okay. So what you could do, you could just I am dropping a mail here, mail ID, right? Like there won't be anything like you won't be able to open the link. No worries. If there is a chance that you are not able to open the link or probably you are not able to copy the link, I have dropped one email. You could write your queries there, right? If you are having any difficulty, obviously our support team will connect with you. Okay. Actually, James, we should not be sharing the link in the group because there are a lot of people and who are not attending the session. They won't be able to understand it. Okay. Okay. So Shiva Shuburu certificate done. Great. So yeah, link is working. People are generating certificates from there. That's great. Okay. So without further ado, I would highly request Ashutosh sir to come again and take the question answer session forward. Just take 3 to 4 questions, which there are some attendees who are having questions, right? So
Yes. Okay. Thanks, Asraf. Okay, let me take the thanks, Asraf. Okay, thanks for everything. Yes. Any question you have? Anyone? Okay, it's all right. Okay, if you guys you can ask. Okay, question. Tilak, I will take your doubts. Okay, later on. It's
Okay,
fine. Yeah. Okay. If you have any doubt, if you have any query, if you have query regarding okay how to join our programs and all, definitely our team will definitely help you guys. And also, if you have some doubts, also you can reach it out to our teams also. Our team also guide you in regarding to that also. Okay. Yes. Any doubt you
yes,
have? Okay.
yes,
Yes. Yeah. Okay.
yeah, I have a question.
Yes,
Okay.
Ram Kumar.
go ahead. Yes, Ram, please
Sorry, I
unmute
was on mute.
yourself and yeah, please ask
Yeah.
us.
Yeah, sorry, I was on mute. Yeah. Yeah, I have a question now. If somebody's experienced like 10 years or 12 years or 14 years, because
Hmm.
we are in one's group, we're
Hmm.
trying to shift the career towards whatever the emerging technologies like EV.
Hmm.
So,
Hmm.
what is your how can we approach right now? For example, if I want to expertise, particularly in BMS,
Okay.
for
Hmm.
example,
Hmm.
then what is the roadmap, and I how to be the industry ready, and what is the roadmap for it? I just don't want just the knowledge, but I want to be the industry ready. What companies are expecting. So, what is the
Yes.
roadmap for that?
Excellent. Ramkumar, I think it will be better if you'll connect with one-to-one session, Ramkumar. It will be better. Rather, I can't explain everything, but I will take some 30-40 minutes, and then it will be better. I will just explain everything. Okay. Yes, Ram
Yeah.
Kumar.
Okay.
Sure. Okay. Yes. Anyone else want to ask any question? Okay. Fine then. Okay. If you have any doubts, if you have any queries, definitely you can reach it out to our team. Definitely we will help you out. Right. Okay. Yes. Yes. Back to Ashraf.
Yes, great. Thank you everyone at the meeting for joining today's EV Architecture Masterclass. We appreciate the time and attention you invested in the session. We hope the breakdown of motor controller, BMS, and sensor system give you a clearer and more practical understanding of how EV function internally, right? So your participation added to the energy of the session, and we are actually really glad to have you as part of our learning community. The resource pack and certificate details have been shared, right? And if you have any question or wish to explore EV or embedded career pathways further, feel free to reach out us. Okay. I have also dropped our mail ID. You could also go to our website. You could just book a counseling with us. And if you are really interested in that, so you could also connect us at uh, at our number, which is provided in our website. You could just go to our website and just search contact us DIYguru, and you will get the everything details like email ID and everything there. And you could connect with us on one-to-one session. So again, thank you once again, Ashutosh sir. Thank you once again, all the attendees here for being with us today. Stay curious, keep learning. See you in the next session. Have a good night. Enjoy your weekend. Bye bye, everyone.
Thanks. Thanks, Ashraf. Thanks to everyone. Thanks to all attendees.
Yeah.
Thanks.
Thank you so much, Abhishek.
Yeah.
Thank you. Thank you. Thank you very much.